This is numbers 4 through 7. Number 4 and 5 say explain why the triangles are similar, and then write a similarity statement. If you look at number 4, I see that we have two congruent angles here, the 100-degree angles, as well as these vertical angles are also going to be congruent. We have that similarity theorem that says that if we can prove that two corresponding angles are congruent to their corresponding angles in the other triangle, then these two triangles must be similar. So all it takes is two sets of corresponding angles to be congruent. And so therefore these two triangles will be similar by a similarity. Now, the other thing it asks us to do is to write a similarity statement. So you can pick any random point that you want. I'm actually going to start with A. So triangle A, and then I'm going to go to CB. And now it's important that we line this up. Is similar to triangle. Well, what goes with A? The E does. What point here goes with the C? The C does. And then what goes with the B? And that would be the D in this case. So now we can say these two triangles are similar. On number 5, this one here, if you look, we've got this side here and this side here. Let's just say that this was, 10, and that means that this would be 5. That means that's 10 all the way around. That means this is 5 all the way around. So no matter what, 10 over 5 is going to work. It's going to line up. So we can say that these two triangles are similar because SSS similarity. And then let's go ahead and just say something like triangle TUV is similar to triangle, and again you want to kind of think about turning this so the Y is really on the top and then the X and the W would come next in line. On number 6, this one says explain why the triangles are similar. Now if you look, I see a 90-degree angle here and a 90-degree angle here, and this small triangle and the big triangle both share this angle right here, which is that reflexive property. C is congruent to itself. So now I've got this small angle and the right angle and the small angle and the right angle that are corresponding, which allows me to say these two, the very small triangle here and the large one, are similar because of a similarity. So now we're going to find DE here. So let's call this X. Now when we do this, you want to look at what they give to you. So we are looking here at this whole side here of 3.25 over, what's the whole side of the bigger one? Well, the whole side of the bigger one would be x plus 3.25. And then that's going to equal this whole side, bottom side here, on the small one as 1.25. So notice I left my two small triangle pieces on top, over the whole side of the larger triangle, 5. And now we're ready to cross multiply. So we're going to do 3.25 times 5, and that's going to give me 16.25 equals 1.25 times, don't forget it's going to be multiplying times this whole denominator, so we got to put it in parentheses, and now we're going to distribute. So we have 16.25 equals 1.25 x, and then we're going to do 1.25 times 3.25 to get 4.0625. And so we'll subtract that from both sides. So 16.25 minus that answer. And we're going to get here 12.1875 equals 1.25x. So now if we divide both sides by 1.25, we are going to get that the value of x here is 9 7/75. Now on number 7, it says, what is BH? And again, you just kind of have to watch out for the whole sides here. So BH is what we're going to put an X here next to. And so we're going to set up our proportion here. Now, when we set up our proportion, we can go ahead and do the same idea that we did over here. Or we can use that theorem that we learned in class the other day, which allows us to say if we have two parallel lines, and really we can put the third one up here, then it cuts these parts proportionally because we have similar triangles. So for example here, we could put x over on the larger side here, 9 is equal to 9 over 15. So it's creating two sets of fractions. Now we can cross multiply, so we get 15x equals 81. And when you do 81 divided by 15 on both sides, x is going to be 5.4 units long.